Lesson 8, homework. Let's quickly mark our homework and see how we have performed in this session of work. I do see my homework question number 1 that I had two triangles joined basically, and if I look at my information here, if I look at it, it seems to me that I have a triangle that I'm interested in. I would just like to highlight the first triangle, AB and C. And in that triangle I can see the right angle, and I do know that the opposite one of course represents my hypotenuse. In this case the x in the first triangle I would like to determine. So I'm going to start referring to it. Let's maybe make a statement here, and I'm going to say in triangle ABC I'm going to work with this triangle first. Let's see what we can say. Now I do know that Pythagoras states that the two sides touching the right angle must be a square, some of them, must be equal to the hypotenuse square opposite that right angle. So I'm going to start by saying that AC square plus AB square must be then equal to the hypotenuse in that triangle, namely BC squared. That's Pythagoras. Now I'm quickly going to substitute my information. AC to be 6 centimeter, that means square, plus AB. AB in this case to be 8 square. And that all together got to be equal to the value labeled in this case to be x, and by Pythagoras square. Therefore I'm going to have 36 plus 64 equal then to a value of x squared. On the left, 36 and 64 together going to leave me with a value of 100 equals to be x squared. One term left, one term right. Remove the square root. I know therefore that x on the left become then square root of 100. So therefore my x value so far going to leave me with a value then of 10 centimeter. And I do remember the first thing that I do is I put it back into my sketch. So important. Keep my sketch up to date. Now if I look at the sketch and I continue with the sketch, I'm going to say now in the next triangle of interest going to become BCD. And in that triangle, according to Pythagoras, I'm going to say then BC square, the two sides touching the 90 degrees, plus CD square, and all that must be then to be together to the hypotenuse, namely BD square. Now we're going to do the substitution. Remember that BC determined previously to be 10 square in this case, plus CD. CD determined, or the wanted one I would like to determine, y, and it must be a square, equals to BD given to me to be 26, and it must be a square. Then I'm going to have, let's put the y square down first. That's the one of interest at the moment. 26 square going to leave me with something like 676, a value. If I bring the 10 square, which is 100, minus 100 on the left, minus 100 on the right, or just bring it over to the right hand side, the sign changed to the opposite, in this case to be a minus. Therefore I'm going to have y square equals to be, now that's going to leave me with a value now of 576. Then remove the square, one term left, one term right. I'm going to have now the square root then of 576, and then y going to leave me then the answer of 24, and that's going to be centimeters. Guys, if you identify the triangles as I've pointed out in the diagram, then it really becomes much easier in doing that. Let's go for question number 2. Question number 2. Let's see what question number 2 is all about. First of all, I see I would like to determine the value of A. So that means I'm going to highlight the triangle at the bottom again. So I grab a color pen and I quickly just highlight the triangle I would like to work with. And then I see that I'm working now, this case, with triangle ABD. So let's start by saying triangle ABD. That's the first one I would like to work with. So in that triangle, according to Pythagoras, I'm going to say now that AB, the two sides, square, plus AD, square, must be then equal to the hypotenuse, in this case BD. Now I'm going to do some substitution. AB to be 3 square plus AD to be 4 square equals to, and ABD to be A, must be a square. Then 3 squares is going to give me 9 plus 4 squares to be 16 equal to be A square. I see that 9 plus 16 going to leave me with a value of 25 equal to be A square. One term left, one term right. Get rid of the square, meaning on the left I'm going to square root 25 equals to A. Therefore I'm going to have a value of A to be namely 5 centimeter. And what is the first thing I do? I write my answer in 5 centimeter. Now I'm going to go and I'm going to head now for the next triangle. My next triangle of interest is going to become this purple one. BCD. Now I'm going to work with that triangle. So I'm going to highlight the triangle first by saying triangle BCD. And by Pythagoras, according to Pythagoras, the two sides opposite the hypotenuse, namely BC square plus BD square must be then equal to the hypotenuse CD square. BC, substitution, BC to be 12 square plus BD, previously determined to be 5 square now, equals to be CD to be the next wanted one to be determined B, and in this case square. So therefore 12 square going to leave me with a value of 144 plus 5 squares to be 25 equal to be B square. 144 plus 25 going to give me a value of 169 equal B square. One term left, one term right. Remove the square on the right hand side. I am going to square root whatever I have on the left hand side, 169. Square root 169 going to leave me with a value then, namely 13 centimeters. What do? I take my answer and I substitute it immediately into my sketch. 13 centimeter for that side there. Now I'm going to be in the triangle CD. Let me see if I can just try to highlight this one here. Now I'm in that triangle there. Let's highlight the triangle first. Triangle CDE. What's going to happen now in this triangle? By Pythagoras, the two sides opposite the hypotenuse, namely CD plus DE equals to the hypotenuse, namely CE. Substitution, CD to be 13 square
plus DE. DE is the C value I would really like to determine in this part of the triangle. So therefore, I'm going to have CE given to be 85, and it must be square. Then I'm going to say that 85 squared, I'm going to move it slightly to the left because C squared, I want to keep it on the left, equals to be 85 squared, going to give me a value of 7225. The 13 squared going to give me 169, minus 169 on the left, minus 169 on the right. If I'm subtracting those two values now, I'm going to end up with a value of 7,056. One term left, one term right. Therefore, I'm going to have the square root of 7056. And therefore, the value of C going to leave me then with an answer of 84 centimeters. And there I have determined the A, the B, and the C value. And once again, my calculation became quite easy by just using some color codes in my sketch and do it step by step, and then it was not too bad. Let's go for number 3. Question number 3. I would like to divide my sketch into two parts, the triangle on the left hand side. So I'm quickly going to highlight the triangle on the left, PQS. So this is the triangle I'm going to work with first. My aiming point is, let me just make a point, I would like to find that side I was highlighting there first. Let's see if I can do that. So I'm going to say triangle PQS. So if I continue now with that Pythagoras, I'm going to say the two sides opposite the hypotenuse. That's this guy is my hypotenuse. The two sides opposite, of course, going to be then PS square plus QS square must be then equal to my hypotenuse PQ square. PS is the side I would like to determine in this triangle. So I'm going to call it and leave it PS plus QS is labeled to be 12 equals to the hypotenuse PQ to be 13. I'm going to keep the PS on the left hand side equal to be 13 on the right already squared to be 169. 12 squared is 144. In other words, on the left minus 144. What I do left I must do right. Minus 144 on the right. Then I'm going to have PS square to leave me with a value of 25. Then one term left, one term right. Remove the square, I'm going to be left then with PS to be square root of 25. And then the square root of 25, so therefore PS going to give me a value of 5 centimeters. And I take that value and I put it in immediately. So PS going to give me a value of 5 centimeters. Let's go now for this one on the right hand side. I'm going to try to take an orange color this time. So the triangle on the left, on the right hand side. So I'm labeling it the triangle now, triangle QSR. Therefore, the two sides again opposite the hypotenuse. Take note that that is my hypotenuse down there for the right hand triangle. So therefore, I'm going to say by Pythagoras, I'm going to say that QS square plus SR square must be then equal to the hypotenuse, namely QR square. QS, substitute is 12 square. I would like to determine this time SR. This is this guy. Let's just try to highlight that fellow down there. SR. I'm going to keep it as SR. That's a plus, of course. Equal to QR, and QR to be 37 square. Then on the left, I'm going to end up with SR square equal to B. And now 37 square going to leave me with a value of 1,369. 12 square going to be 144. Minus 144 on the left, minus 144 on the right, going to give me a value then of minus 144 on the right hand side. Therefore, SR square, if I'm subtracting those two values then from each other, it's going to leave me with 1,225. One term left, one term right. Remove the square, therefore I'm going to have SR going to leave me then with the square root of 1,225. And then SR therefore going to leave me then with the answer of 35 centimeters. And I take that value and I put it back into my sketch. Now I can see that the X, which is PR, so therefore I can make the statement now by saying that PR is similar than PS plus SR. Therefore, PS determined previously to be 5 plus SR to be 35. And if I add the 2 now, I'm going to have, and keep in mind that PR, of course, is the value of X. Going to leave me then a value of 40 centimeters. Guys, once again, by playing with color codes, it really helps me in seeing the calculation into it much better, so that I can see what to determine and how to determine. And I would really also like to invite you to make use of color pencils to start doing your calculations. Get used to it. It's a nice habit to do. Let's go for question number 4. Question number 4. I'm going to start now this time with a triangle BCE. Why will I like to start with this triangle here? Because this is the triangle where I have the most information available to me. So I'm going to try my best first to determine the value of EB. So I'm going to highlight it here, triangle BCE. Therefore, in that one, I know that the hypotenuse is the side opposite the right angle. So I'm going to have BC square plus BE square is equal to the hypotenuse CE. Substitute the values. BC, namely to be 112 square, plus BE, I would really like to find the value BE equals to the hypotenuse 113 square. I would like to keep the BE on the left. Therefore, 113 on the right going to give me a value of 12,769. The 112 minus it on the left square, of course. What I do left, I do right, minus, and the 112 square going to give me a value of 12,544. If I'm going to subtract those two values now, it's going to leave me with an answer of 225. Remove the square on the left, meaning square root on the right. And that's going to leave me now our answer BE to be 15 centimeter and I take it and I put it in immediately at my sketch. Now I'm going to be in the triangle on the right. ABE. ABE. So I'm highlighting it. Triangle ABE. Again, opposite the 90 degrees, I'm going to find the hypotenuse. So the two sides opposite the hypotenuse going to be AB square plus BE square equals to my hypotenuse AE square in this triangle. Substitute. AB is x I would like to determine for this triangle. BE, previously determined, 15 square equals to be AE 17 square. Therefore x squared I would like to find for now. 17 squared on the right is 289 minus the 15 squared on the left minus 15 squared on the right minus 225 in other words. If I'm subtracting those two values now, I'm going to be left with the answer of 64. Therefore x going to give me the square root of 64. Answer for x to be 8 centimeters, and I put it in immediately, 8 centimeters. Now I'm going to be on the triangle on the right. So I'm going to go for triangle. Now the triangle on the right is going to be, let me see if I can quickly highlight it, the purple one. This is the big one on the right hand side. There we go, all the way, and therefore the triangle is ACD. Therefore the side opposite the 90, the right angle, is going to be my hypotenuse. Therefore the two sides going to be AD square plus AC, the total one of that triangle, AC square, equals to the hypotenuse to be CD square. Substitute AD to be given 100 square. Now guys, the AC is that AB plus the BC. In other words, it's going to become the 8 plus the 112, the two together to be AC in total, and it must be square, equals to be CD, which is y square. Therefore 100 square is going to leave me with a value of 10,000 plus 8 plus 112 is 120 to be square, equals to be y square. Therefore I'm going to have 10,000 plus, and that's going to give me 14,400 equals to be y square. If I'm subtracting or adding those two, I'm going to have 24,400 equals to be y square. And I do know now square root on the left now equals to be y, and I'm going to have, if I'm rounding it off my answer to one decimal, I'm going to have 156,2 centimeters. Guys, once again, a beautiful calculation. Pythagoras, play with color codes, it make my life much easier. Let's go for the last question. The last question of the homework, of course, as I have mentioned, question number 5. Guys, sometimes you will find that the calculations, the sketches that normally looks the most difficult perhaps, are the easiest ones of them all to do. The first triangle I would like to highlight is this triangle AGF. It's a triangle, and it's a very particular kind of triangle. It is a right angle triangle. It just lies on its side. So I'm going to say triangle AGF. Then I know that Pythagoras again. Now guys, we must remember that this guy here is going to become my hypotenuse. So according to Pythagoras, I'm going to say that AG square plus AF square going to be equal to the hypotenuse, in this case GF. Substitute AG to be 3 square plus AF to be 4 square equals to be GF, and I would like to find that, so I'm going to keep it as GF square. That's going to give me 3 squares to be 9, 4 squares to be 16 equals to be GF. Therefore 9 and 16 to be 25 equals to be GF. And that's a square, I must not forget the square. Remove the square on the right, therefore I'm going to have the square root of 25 on the left equals then to be GF. So therefore GF going to leave me a value of 5 meters. What do I normally do? I take it and I put it in immediately. So that fellow down there to be 5 meters. Now I'm going to be in the red triangle. And the triangle I would like to highlight now, in this case going to become then triangle, let's see if I can fit it, triangle CFG. So therefore, from this one, that fellow there is going to become the hypotenuse, the x. So I'm going to start the two sides opposite the hypotenuse. CG square plus GF square got to be then equal to the hypotenuse CF. Substitute. Now guys, because this is a cube, I know the cube that all sides going to be the same. That means if that's a 12, it means that that fellow down there also must be a 12. Therefore I'm going to have CG also then to be 12, got to be squared then by Pythagoras. GF previously determined to be 5 square equals to be CF, in this case to become x square. That's going to leave me with 144 plus the 25 equals to be x squared. Then that's going to give me a total of 169 equals to be x squared. Remove the square on the left, square root on the left. 169. Therefore x on the right. That means that x going to leave me with the answer then of 13. That diagonal 13 meters, not centimeter, 13 meters. And that was not so bad in doing that calculation then. Again, if we start playing by the color codes and we start with a place where we have the most information, these calculations really become very nice to do. Right guys, thank you very much. I hope that you have performed quite okay. Make your corrections, make sure that your sketches also by color codes look according to mine. Make your books nice, and till we go for the next lesson, enjoy. Thank you very much.